This is problem 18 in chapter 8, where a hammer hits a nail and drives it into a board. The hammer has a mass of 0.45 kilograms and is initially traveling at 7 meters per second. It strikes the nail and pushes it into the board 1 centimeter, which is 0.01 meters. First thing we need to do is find out how long does it take for that event to happen, for the nail to get hit and go into the board. And we'll use, we'll assume this is a constant velocity, and we'll use the definition of average velocity as that. So delta t rather, equals delta x over delta v. So the delta x is 0.01 meters, a centimeter. The change in velocity is the average velocity. So if we went from 7 meters per second, we came to a stop at 0, the average is half of that, 3.5 meters per second. And when you calculate that out, t equals 0.00286 seconds. The next part of the problem says, what's the average force acting on it? And that's the change in momentum over the change in time. The change in momentum is the mass times the change in volume, so 0.45 kilograms times 0 meters per second minus 7 meters per second divided by 0.00286 seconds. And when you calculate that out, you get that the force is minus 1100 newtons. What's the minus sign means? It means it's in the opposite direction of the velocity. So the force is upwards, which makes sense, has an average value of 1100 newtons.